Hey everyone.
Thanks, man.
So, thanks for having us. We're really excited to be here and talk about goquery. Just so we know, how many people here know what goquery is or have heard of it? Okay. Who here feels they really know what goquery is? All right, awesome. So, we're going to start off this talk not with goquery, but who we are and like why we're here. And so this is us. I'm sorry that my picture is old. I won't let it happen again. So Andrew's going to introduce himself.
Hello, everyone. My name is Andrew Guthrie. I'm a full-stack developer up in Vancouver, Canada. I'm the co-author of the goquery library alongside Mitchell.
Yeah. And so I'm Mitchell, and I'm Obelisk on the osquery GitHub, if you're familiar with that. I've been working on osquery since 2015, doing a lot of like Mac OS and like more Linuxy stuff. And then I had this idea to build this tool and worked with Andrew to get it done. And that's what we're going to talk about. So our presentation roadmap is basically answering hopefully all the questions that you have about osquery or goquery. And we're going to start off with why. Like, why did you build this tool at all? And we're going to talk about what it achieves. We're going to talk about what it doesn't achieve. And we're going to talk about what it can be used for. And like why you might want to use it in your infrastructure. Then we're going to go on to Andrew's section and we're going to talk about how. And we're going to talk about the osquery distributed API. We're going to talk about the LS and CD emulation that goquery does because osquery is stateless and has no concept of a present working directory. And then we're going to try and touch on aliases and the goquery config if we have time, which is a way to sort of streamline your usage of this, especially between multiple investigators or users. And then we're going to go on to where. So goquery was released a couple months ago with our V1 update. We're going to cover our V2 update that came out last week that makes it much easier to do things like customization and putting in your own custom commands to do things within goquery. And then we're going to talk about where we want it to go and some future features that we want to work on. But we got to address that first problem, which is what is goquery? So first off, let's say that you have a machine that's running osquery. It's going to be generating all of this data all the time. You're like pulling it back, running it through lambdas or something like that. And you're like, okay, this is great. But then what happens when all of a sudden you see something and you're like, oh, that's not good. I need to investigate that. And then say it's on someone's laptop and then they've gone home for the day. So now they're outside your corporate infrastructure. You can't SSH easily to their machine. So we want to solve this. So you got the logs back though, so you know something's wrong. So you have osquery. So if we put our osquery backend up there, okay, so now what can we do? Well, if you're using the distributed API, your analyst might be, okay, well, I want to go in and I want to look at this. So I'll make a distributed query which goes up to the backend and then pushes it down to the machine. The machine will run that query and then push the results back. So that's nice, but it's not super convenient and it requires a lot of understanding of the backend, which is a lot to ask of your analysts, and especially if you're spinning new people up, now you have to explain that. You can't just say, oh, you just connect to a machine and then triage it. You have to be, okay, so we have this thing called osquery, and it's got this backend, and you've got to do all this stuff. So if we have that, well, then we can just look at it this way. And so, okay, so that's simpler. But again, we don't need to worry about the firewall anymore because both things have access to the backend. So the firewall goes away. And then what goquery does is, well, can we make the backend go away? We can't technically make it go away, but we can make it so you don't have to think about it. So goquery makes osquery look like that. So your analyst can feel like, oh, I'm directly connected to this machine. And this is what it looks like in practice. I also didn't create this GIF, so I have no idea when it ends. So it's just going to stop at some point. Cool. All right. So that's what it looks like. So the idea is to make it feel like you're directly connected to this machine and for it to feel nice and snappy. So, all right, but what have you done for me lately? Like, what can I actually achieve with this? So let's talk about this particular machine again and how like an analyst might be connected to it. So another advantage of this is if you want to do triage and you have like lots of people with access to this system, the more people who can access it, the more benefit you get from this. But that also means that if you have this remote system, that it's sort of worrying if they can change system state and do a bunch of things that might take it down. Really what you want to be able to do is limit it to sort of a set of commands that you're comfortable with. Yes, you can use this for triage, even if it just helps you push in the right direction, be like, okay, now I need to mutate system state because I know what I'm looking for. What you want to avoid are perhaps things like this. Because as soon as you have things like this, now it has to be like, okay, well, who can use this and why, and like, what are they going to do, and do they need permissions from some other team? It slows down the ability to use it. But because it's based on osquery, well, we can look at these things and we can be like, well, a lot of these translate very nicely into queries. And the things that we don't want to do, there is no query that you can write to RM a file. And so now we have a system where the language itself prevents us from doing the system mutations and the dangerous things that we want to prevent. And it just looks like this to the end user. But a number of people in here, I'm sure, have deployed osquery before. Like, this might be how it looks, but that's not how it is. What it actually is with our backend in here. And because we have to go through the backend, we can say, oh, well, every time you get a request, I want you to log it for me. And so now, whenever anyone uses goquery, you not only can see what request did they make, because it gets logged, but you can also see what the host sent back. And so now, in that problem of who watches the watchers and like what happened on this host, why did you do this, you have full logging of this, and you get it basically for free. But again, infrastructure doesn't look like this. Because if anybody in here is running osquery on a single host, well, that's cute, but not super useful. So our infrastructures generally look like this, with many, many hosts. And so now you have the access problem, which is, okay, if I'm using SSH, I have to maintain a bunch of keys, or I need to maintain a bunch of permissions and users. But if you're using a backend that supports grouping, like OS control, fleet, upticks, well, your backend starts looking more like this. And so now you have tiers of servers. And you can say, all right, but depending on the user that's using goquery, maybe they can only access dev, prod, and test. Security can access corp because they're triaging these sorts of things. Maybe you have some PCI teams and they have their own tier and only they can access that. And you can use that to manage compliance. So that's why, but now let's cover how.
Awesome, thanks Mitchell. So yeah, now it's pretty clear how goquery is useful. But let's go over a bit about the magic behind the scenes. How is it actually implemented? What's going on and what's needed? So we can start with an illustration, an overview of all the actors. We'll go over their interface with each other, their contract. Starting with, on the left here, we have goquery. And goquery requires 3 specialized APIs to work. So in your backend, whether it's your own custom rolled backend, OS control, fleet, upticks, it's going to need these 3 APIs for the features that goquery provides. I'll go over in detail a bit later. On the flip side, we have the distributed API with osquery on your host, and that's communicating with your backend. Javier did a really good presentation on the distributed API yesterday. You can check it out. I won't go into too much detail of how that's actually implemented. But we also have some other endpoints, log config, but those aren't required for goquery to work. So moving on now, we can look at, this is the details of how these APIs actually need to be implemented. So again, it's only these 3 specialized specific APIs for goquery. They're pretty self-explanatory, but we'll just run through them pretty quickly here. So check host, string input, you have a UID. You're going to ask your backend, do you have a host present, host enrolled in your state that matches this UID? If it does, your backend is going to send back, yes, here's the host, here's this information, here's this name, version of osquery it's running, and goquery is going to hold on to that. The next API we need is schedule query. So it's exactly what it sounds like. now that we have the host information, we can package that along with a string query that the user actually wants to run, post that to the backend, and it's going to do some stuff I'll talk about later, but it's going to send us back a query name, a query ID. Super unique. I think you can see where I'm going with this. Next, we're just going to feed that query ID, the unique one, into a fetch results API. So this one is just, again, a string, unique name, and we're going to pull the backend, and if the results are ready and ready to be serialized, it's going to send that back to us, and that's just going to be a JSON array of dictionaries representing our rows. So yeah, pretty simple. That's essentially it. That's how goquery interfaces with your backend. But let's go over how the user interfaces with goquery. And they do so via commands. You can have external commands. You can write your own custom commands. goquery ships with a lot of commands. Some of them self-explanatory. Some of them maybe not so much. Like mode, for example, just changes the way the result query is printed on the screen. Help enumerates all the commands in their help text. History is just like your last few commands. But none of these use the API that we just went over. Luckily, connect implements all of them. So I can run you through the connect command, and it'll probably be really clear and make a lot of sense now. So what the user's going to do is they're going to open goquery shell, and they're going to type .connect space UID. And so the first API call, like we went over, is check host. So we have the UID. We're going to ask the backend, like, hey, again, do you have this host enrolled? Like, has a host with this UID posted to enroll? And it's going to send back that host information. So goquery is going to hold on to that. This is part of the connect process. The next step is we're going to schedule a query. We want to load all the available tables that our host running osquery has. So a post call to the schedule query API. It's going to go to our backend. Our backend is going to generate a unique query ID, a unique query name again, and it's going to hold on to this. It's going to, right away, it's going to reply back to goquery. It's going to say, here's your query name, your token, like use it to check up later. In the meantime, as a separate actor, our host running osquery is going to check in with distributed read against our backend. And so once it checks in, after some amount of time, our backend's going to be like, yep, I do have a query for you to run. I want you to tell me what tables you have. So osquery is going to pull that down, do some work, get the results, and it's going to post that with distributed write up to our backend. In the meantime, goquery is actively polling to fetch results with that unique query ID name we got. And when that's done, eventually we're going to get our results back. So this goes over the entire connect process. And so at this point now, we have a host we know exists and is active in our backend. We have a list of the tables that the host has, so we can do some cool stuff like the tab autocomplete you saw earlier for select star from table names. And yeah, this command goes over all of the APIs that goquery actually needs. So now that you understand how connect works, you can probably piece together how these commands work. So schedule is just a call to the schedule query API. And this one doesn't actually block and wait. It drops you back into the shell, so you can fire off a bunch of different scheduled queries. .query is schedule with wait, so it'll call schedule, and then it'll start that fetch results polling loop. Resume is how to go back to a scheduled query you might have long running and you want to come back to later. And .all is actually an alias. So goquery supports aliasing. You can write your own aliases that are parameterized. Aliases can call other aliases. It's kind of like a directed acyclical graph. But .all here is just select star from blank. Super cool. So that's how the goquery commands work. But you might be thinking, having written out your own backend, there's going to be a bottleneck here. It's going to be super slow. Like we're limited here by the check-in time that our host is checking for, is there any work for me to do in our backend? So that'd be super slow if every time you write a command, you got to wait maybe 30 seconds or 2 minutes for your host to do the check-in. But luckily, osquery has a feature called accelerated mode. So as part of the distributed read API, you can send back an accelerated field, and goquery will check for that. And if it's present, it'll enter what's called accelerated mode. And so in accelerated mode, we're actually going to be polling and doing a check-in every 2 seconds for a specified amount of time, whatever that accelerated field is. So that's super handy, and that makes it so that when we're using goquery, it could be much snappier. It'll pick up on our queries right away, and then the host will remain hot for a given amount of time. You may also remember that Mitchell mentioned CDLS support. It was demonstrated in the video. Pretty cool. goquery holds on to all the state internally. So because osquery is kind of stateless, it doesn't have a concept of present working directory, we just mock that in goquery. So we have the host information. The cd command is going to assign a string to it. And when the user hits ls, it's just parameterizing a query. It's just calling schedule query with a parameterized select star from file where path equals blank. So yeah, again, that's implemented all with only those 3 APIs, those 3 endpoints that goquery needs specifically. In addition, goquery can keep track of the state of multiple hosts at the same time. So an analyst can be connected to a bunch of different machines investigating, and they might look something like this. So they could be looking at Mitchell's machine, Andrew's Windows machine, because osquery is cross-platform, or something that's messed up on production. And one cool property of this is that because osquery is stateless and doesn't modify system state, it's kind of mutable, and our backend is returning unique query IDs, unique query names, multiple analysts can work on the same host at the same time without interfering with each other and without even knowing about the presence of each other. So yeah, I hope that there was a pretty good explanation of the endpoint goquery needs, what kind of integration it can do. And yeah, you want to take it from here?
Cool. All right. So hopefully it's clear on like how goquery like achieves this and how it can sit on top of your existing osquery infrastructure using the distributed API to build this almost remote shell functionality, but is much safer and fully logged. And now I want to go over some of the mistakes that I personally made when first coming up with the design of this project before it was corrected both by the community and Andrew. So let's talk about V1 of goquery, which is the one that people here, if you've played with goquery before, have probably seen, because this was the architecture of goquery that I thought was a good idea, which is you would check out goquery, and then you're just like, okay, so I want it to work with my infrastructure, and I want to do a bunch of things. So you'd make a bunch of changes to it, which was great, and then you'd compile it, and then you would deploy that goquery binary. And so to me, this made sense, except when other people looked at it, they were like, okay, this part is a problem, because if I'm making changes to it, and I want it to integrate with my own API, how am I supposed to pull in new changes? That makes it extremely hard to merge. And then when I make changes that I do want to upstream, that's also very difficult. So we ended up with this system where everyone was like, wow, goquery is great as long as you only want to use it in the test environment because it's impossible to use otherwise. So Andrew luckily corrected this, and it was pointed out by some other people that we should re-architect it. And so this is the version that came out last week, which is version 2. So now the process is you write the code that interfaces with your backend and any custom commands, because now you can write your own goquery commands that can get compiled into your binary. So if you say push an extension table that does something particular, like say memory forensics, and you want to be able to, oh, what if I could just pull that data back and immediately parse it all within goquery? Well, now you can write a command and insert that directly into the goquery binary that you're deploying to your infrastructure. So you work on this for a while, and you get it working, and then you pull in the goquery source code, and then you ship the binary. So this means that all of the code that you have to write to make it work with your infrastructure or any custom commands that may or may not be open source can be isolated from the goquery code, but any goquery changes that you want to push back up to the community are also isolated. And so when it goes to, oh, okay, well now I need to track this in SVN, well, now all of your code can just go to your internal GitLab or Bitbucket, and all of the goquery changes just go right up to GitHub. And so you can iterate much more quickly, and it's much faster to use and get new versions out specific for your infrastructure. But that's just where we are today. So where do we want to go? So in version 3, Well, there are some problems that we can't solve yet this way. So let's go back to what our hypothetical example was of an analyst investigating 3 hosts. If you have something bad that's happened and you're like, oh, okay, I need to definitely check for this, what do you do, again, when your infrastructure is huge? You have the analyst connect to every single host? That seems bad and hard and inconvenient and likely to miss something. But again, this is the view of what the analyst sees. This is the view of what we see. So we would like to implement a new system that says, oh, hey, I have a query and I want to run it everywhere on all of the hosts that you know exist. And then I want to be able to say separately, okay, now that I've gotten all that data back, I want to get it and I want to save it to a file such that I can do my own processing on it and figure out exactly if we're compromised, what the IOCs were that I found, or how to use this and make sure that we're in compliance or whatever the goal is. And that's basically goquery and how it works and why. So we talked about how we can abstract the osquery distributed API to build this. We talked about how it allows you to do the things that you want to do while also at the language level disallowing you from doing the more dangerous things. And we talked about the new goquery build system that will hopefully make it much easier to integrate with your enterprise regardless of what your backend is. And just to mention here, OS Control has support for these APIs already, and there is an implementation available for it in the goquery repo. Fleet also has these APIs, and there will be a pull request coming up at some point soon that will show you how to implement it with that. But if you're running something home-rolled, again, like Andrew said, you only need to implement those 3 APIs. And that's it.